So far we've talked about elements and compounds. So today we're going to start talking about mixtures. A mixture is a combination of two or more substances that are not chemically combined. So as opposed to compounds that are chemically combined to each other, mixtures are not. So because of that, that means they do not react with each other. They are just mixing with each other instead. So even when you have mixtures that may look like they become one, their molecules are actually staying separate. So that means there's no chemical changes. It's all just physical change by possibly changing the appearance. Um, there's lots of different examples of mixtures, and we're going to get into some examples more as we go through types of mixtures. But one example that a lot of people don't think of is pizza. Pizza is a mixture. You mix the crust and the sauce and the cheese and whatever toppings you have on there. The pizza itself is a mixture. You're mixing those things. Salad is a mixture. Salt and water is a mixture. All these things that you mix together but they don't chemically combine, they're considered mixtures, and there's lots of different types. So first off, mixtures can be separated by some kind of physical means. Some are more easy than others. So if you have a salad, you can easily pick out the tomatoes. That's not difficult to do. It's a very, very easy process. Some require some more difficult processes. There are still physical means, but they can be separated. So one process that sometimes is used is distillation. So if you distill something, such as salt water, you are separating that mixture based on their boiling point. So you will basically, it's boiling that water until it becomes a vapor and it leaves that salt behind. That can be done with several different compounds and mixtures. Magnets is another way. If you have a mixture of components that one is magnetic and one is not, you can use a magnet to separate things out. So if you have aluminum and iron, aluminum is not magnetic, whereas iron is. So if you used a magnet, you could easily separate that iron out. And even though they look similar, because if you tried to just by looking at it, it definitely would not be super easy. Another way, which I will try to remember to bring in to show you, is a centrifuge. So if you have blood, when they have blood and they want to separate it into its parts, like separate the red blood cells, the plasma, they put it in this little machine that spins super fast, and it has test tubes with the blood inside of it. And by spinning it, it physically separates the different components of the blood. So those are a couple ways that you, even some of the more difficult mixtures to separate, they can still be separated by physical means. One thing that we talked about with compounds is how there was a specific ratio of how the atoms join together. Well, in mixtures, there's no specific ratio because they're not chemically combined. So it doesn't matter how they combine. If you have, again, we'll just stick with the salad example. If you have a salad, there is no law that says that you have to have so many pieces of lettuce per so many pieces of tomatoes per so many croutons. You can throw as many of any of those as you want. It's not, going against the laws of chemistry and physics. They can combine however is possible. So the example I have on there is granite. So granite is, if you've ever seen like granite countertops, it's basically just a mix of a bunch of rocks. It's a type of rock, I guess. It's a mix of a bunch of rocks, but it doesn't join any specific combination. There's no repeated pattern. It's a pretty random pattern because it doesn't need a specific ratio. Alright, so you should have a little comparison chart on your notes to fill this in. So to break down and compare compounds and mixtures, because they can be easy to mix up, though they do have opposite qualities, you just got to keep them straight. So compounds are made of elements, whereas mixtures are made of elements, compounds, or both. So a mixture could be a mixture of lots of either, an element or a compound, or possibly both, whereas compounds, you're just making them up of elements. Secondly, compounds, when they form, have a change in the original properties of the component. So we talked about how different the compounds are from the elements that make them up, whereas mixtures, you're not changing the original properties of those components because you're not changing the component at all. So, like we said, with a pizza or salad, lettuce is still lettuce, tomato is still tomato. It's not going to change those properties. Thirdly, compounds can be separated by chemical means. You can't just pull apart a compound, but some can be separated by electricity or other chemical means, whereas a mixture can be separated by physical means. Some a little more easy than others, but it's still not too difficult. And then lastly, mixtures and compounds. If you have compounds that have to have a set ratio of components, remember the atoms only join in certain ways based on what bonds they're going to form, whereas mixtures, you can throw as many of each component in, it doesn't matter, it's not going to offset anything with that. And the last part of mixtures is that we have two different types of mixtures. So I'm not sure that your book uses these terms, but these are two pretty common terms that we use. So if you recall way back in 7th grade, we learned about the prefix homo and hetero. When we learned about genetics, we talked about homo and heterozygous. And in this case, we're talking now about words homogeneous and heterogeneous. So remember that homo means same and hetero means different. Actually, for extra credit, what I want you to do is to write same above homo in the word homogeneous and write different above the part hetero in the where it says heterogeneous on your paper. Make sure we're listening so we can, and also gives you a good reminder on your notes. So write same above homo and write different above hetero, and I'll give you extra points when I'm checking through that. Anyways, homo means the same, so that means in a homogeneous mixture it has the same uniform appearance and composition throughout. So rather than being able to see the individual pieces of that mixture, it all mixed together and blended perfectly. So this would be something like salt water or sugar water. It blends perfectly so that you can't see the salt in the water, you can't see the sugar in the water. That's why a lot of people tend to think of it as a lot of people at first, before they learn about this, think of it as a chemical change, because the salt kind of disappears, but it's not actually disappearing, it's just those molecules spread out perfectly throughout, that now it's uniform and it all looks like one thing. So that's a homogeneous mixture. A heterogeneous mixture is where you can see the different substances. So this would be something like a salad or a pizza or a bowl of Chex Mix. You have a mixture of different ingredients, but you can see all the individual pieces. So it's different throughout. You can see the different things. So use your prefixes to help you remember that. But we will go through and we'll keep talking about those different types and do some activities with those things. But remember homogeneous and heterogeneous for your different types of mixtures.